Let us start with the CT scan. First of all, who discovered CT scan? CT scan was discovered by Xray Hounsfield. Okay, he was the one who invented the CT scan. Now, let us move towards what is the difference between the X-ray and the CT scan. So the first of all, let us move towards this image to understand more properly. Okay, so this is the X-ray. This is our X-ray tube. This is our patient, and here we have our film where we obtain our image. So what this X-ray does, it does give 2D image of the 3D body, right? So suppose you have a anomaly over here. This X-ray is coming out, passing through the patient's body and getting the image on the film. Now there are many probabilities that this anomaly can present anywhere over here. You are not able to pinpoint the specific location of that anomaly or the what organs it is involving, what damage it is causing. You can just say, okay, if there can be an anomaly present, it just detects the presence of anomaly. Any foreign body or tumor, it just detects it. It doesn't give a specific position, the organ, till extent it is spread or which organs it is involving. So to get this specific position and getting the 3D image of a 3D body, we got a technique, we call it as CT scan. Okay, so what the difference in X-ray and CT scan is that, see, this is your X-ray tube and this is our detector. This CT scan, this X-ray tube and the detector is moving in a circular manner around the patient and exposing the patient from all the 360 degrees of the patient. So we are getting a 3D image of a 3D body. So we are able to pinpoint and locate the anomaly. We are able to see how much extent the anomaly has spread, which organ it has involved, the extent of involvement of organ, and all these things are obtained through the CT scan. So this is the advantage of CT scan over the X-ray. But the problem is that the CT scan exposes the patient to lot more X-rays as compared to the radiogram or the conventional X-ray machine, right? Now let us move towards what is CT or computed tomography. Why we call this as a computed tomography? So the first one, this is our X-ray tube. This X-ray tube is throwing the X-rays in a fan manner. Not like this. It's not pencil, it's fan manner. And here we have our detector. Now this detector move around the patient in all 360 degrees. Let us have a look over this video. So see, this X-ray is moving in 360 degrees around the patient and exposing the patient in all the direction. Since the patient is exposed in all the direction, you are getting a section of a body in the form of image, right? In form of image, and this image we call it as tomogram, right? And since this is assisted by computer, you call it as computer tomography, right? This is the reason we are calling it as a computer tomography. Now this degree of white or the black or the degree of black and white in the CT scan, you define it in particular unit, and that unit is named after the inventor of the CT scan, the Houndsfield unit. Okay, before moving towards the Hounsfield unit, let us just read a sentence about the basic principle of CT scan. I have explained that in detail in this working of CT scan, but just let us go through it for completion's sake. That is, a thin section of body are achieved to create the axial section of a body. A thin sections are achieved and they are put together to get a proper axial section of the body. So let us move towards the Hounsfield unit and its relation with attenuation. So first let us see the definition. We will read this definition and then we will break it down and understand the definition. The first one, the definition is Hounsfield unit is a numerical value given to each tissue depending on the degree of attenuation of X-ray by that tissue. So what does it say? It says that Hounsfield unit is a value. This value is given to a tissue and this value depends on degree of attenuation. Degree of attenuation is degree of absorption of the particular tissue of X-rays. How much X-rays are absorbed and how much X-rays are allowed to pass, this will give the Hounsfield unit of a particular tissue. So what is the formula for Hounsfield unit? Hounsfield unit is equal to 1000 into mu x, that is the mu of a particular tissue, minus mu water upon mu water minus mu air. Here this mu is the linear attenuation coefficient. Okay, so what we are able to derive from this formula is that Hounsfield unit depends on this linear attenuation coefficient, and this linear attenuation coefficient depends on the atomic density of the particular tissue. How? Atomic density is directly proportional to the degree of attenuation. So what we can say that greater the density, greater will be the degree of attenuation, greater will be the absorption. Lesser the density, lesser the attenuation, lesser will be the absorption of X-rays. Okay. Now let us move towards how this scan is obtained and how do you get the scan. Suppose this is a axial section of the body. This axial section is divided into small square by this lattice form. So these are vertical lines and then we have the horizontal line to divide it. Right? Now let us take in consideration this first unit, this first square. This square is exposed by the X-ray in all 360 degrees. So these are the X-rays which is exposed to it in all 360 degrees. By exposing these, the degree of attenuation is calculated. That means the Hounsfield unit is calculated. So suppose this is square 1, so Hounsfield unit 1, and this is square 2, 3, 4, 5, it goes on till x. So Hounsfield unit of 2, Hounsfield unit of 3, it goes till Hounsfield unit x. And when you collect all these Hounsfield unit, you're going to collect this and you're going to obtain the CT scan. Right? So in this way you obtain the CT scan of a particular section of body. Now before moving forward, I want you to learn the definition or understand the definition of resolution. Okay. So what is resolution? The resolution means the smallest point you can see or obtain. You call it as resolution. Now the resolution for 2D image, we say pixel, right? You ask how much pixel the camera is, right? So because you're getting a 2D image. But in case of 3D, this resolution gets the unit as voxel. And how you're going to learn it? 3D volume voxel. Okay, so this resolution played an important factor for the advancement of this CT machine techniques. Now let us move towards the Hounsfield unit of different structures. So this is a Hounsfield unit. These are the structures we are going to discuss. Structures, and these are the hypo or hyperdense, whether they are hypo or hyperdense. So let us see what do you mean by hypodense. Hypodense. This hypodense structures appears black on CT. We are just discussed how we are going to, like in previous lecture, how we are going to learn that hypodense is black. Hypo, oh my god, you recall God, you think of God when there is darkness or black outside. So hypodense, hypo, oh my god, black. Then opposite to hypo you have hyper. So hyperdense will appear white, right? Now the catch or glitch here in this CT scan is that isodense structure doesn't mean it is iso or in equilibrium with both of these. Here the isodense structure means the reference structure. It means reference structure. Okay, doesn't mean that isodense structure has a Hounsfield unit as 0. No. Whichever structure you can use it for the reference purpose, or whichever structures you are using for the reference purpose and then labeling whether the surrounding structure is normal or abnormal, you call it as an isodense structure. So let us move towards the Hounsfield unit and the structure. The first one you have plus 1000 and it is shown by the cortical bone. Okay, not the spongy bone or the calcareous bone in center. It is shown by the cortical bone outside. Means suppose this is a section of bone, so this is a cortical bone and then we have a spongy bone, right? The cortical bone, and it is most hypodense, that is the most white. Most hyperdense, that is the most white. Sorry. So most hyperdense, most white. Okay, then we have plus 100 and it is a value by acute hematoma and it is hyperdense structure. Then the important point I am going to highlight over here, this section, because it is an isodense structure. So plus 30 to plus 40 value is exhibited by the liver or the grey matter, and you are going to take it as isodense, that is the reference structure, right? See, observe this thing, its Hounsfield unit value is not 0. The Hounsfield unit value 0 is shown by the water and it is hypodense structure. Okay, so are you going to learn that HU value of water is 0? Water has a 0 calorie, or the calorific value is 0 of water, so even the HU value of water is 0. Then is minus 100 and it is shown by fat, which is a hypodense structure, that is it appears black. Right? Then is minus 1000, it is shown by air and is the most hypodense structure, that is it is the blackest of all. Right? I want you to learn one more thing which is very important in the MCQ point of view, is that on CT scan the fat is hypodense. Right? On CT scan the fat is hypodense, that is it appears black. Whereas on USG, this fat is hyperdense, that is it appears white. It's not hyperdense, it's hyperechoic. Okay, hyperechoic is used for the USG, so it appears white. Okay, so here we are done till the CT scan part 1.